In this video we're going to take a look at how to write a Boolean expression for a given logic circuit and also to draw an equivalent logic gate for a given Boolean expression. Now you might have to do this either way in the exam. So in the exam you might get a Boolean expression like this: A and B or C and D equals Q, and you'd be expected to draw out the logic gate circuit for it. So pause the video for a moment and just have a stab at this yourself, and when you're ready unpause the video and see how you've done. Okay, so how did you do? This should have been the logic gate circuit you came up with. When presented with something like this in the exam, it often helps for you to start compartmentalising the various parts of the Boolean expression. So if we take the OR, which separates parts of the expression, and place brackets around the various statements, you'll see here we end up with A and B, so that has to be an AND gate, or C and D, and these two things are being ORed together. Well, if they're being ORed together, then the OR is going to end up at the outer edge on the right hand side of the diagram, and it's going to be the results of A and B feeding into it and the results of C and D feeding into the OR. So now let's try it the other way round. Here you've been presented with a logic gate circuit. You have to study that carefully and determine what the Boolean expression for it is. So again, pause the video and see if you can come up with the Boolean expression on your own before checking your answer. Okay, so how did you do with this one? Let's just work through this so it makes sense. So we can see here we've got A and not B, or not A and B. And again, it sometimes helps people to compartmentalise the parts of the expression by separating the parts from the ORs. So if we look here, we've got A and not B. Well, because we've got an A and not B, we're going to need this AND gate. So we've got A there and not B. So we just put the not just on the B bit. So there's your A and not B. So that's that section taken care of. We've also got a not A and B. So we've got not A and the B. These two expressions are being ORed together, so the output of the two AND gates goes into an OR gate.